Welcome everyone to this session. Thank you for joining. My name is Dan Gordon. I'm the Director of Technical Evangelism at Traceable AI. This is Effective API Security with Traceable. And really we're going to talk about, and hopefully your takeaways will be how you should think about API security and why application context and behavioral analysis is an important part of that. A little bit about myself, as I mentioned, technical evangelist. I've been around all of this for probably more than I should be admitting. I've been developer, IT operations, security ops in the old days, a security architect, product managed several DevOps products, most recently DevSecOps evangelist at GitLab, and currently loving being an API, being at Traceable AI and talking about the importance of API security as we look at how we secure all of the software and why, and I'll talk about during the session why we think it's so important to focus on the API side of it as well. In general, what we're going to do during this session, the next 50 minutes or so, is set a little bit of context, why APIs are a challenge, what's the crisis going on, why do they require a kind of a different approach, why are web solutions not, security solutions not enough. We'll look at and talk about what we believe are API security pillars that we should be paying attention to, and what they mean. On each of those, we'll dive into the Traceable product, at least, and show how that shows in our product, to give you a sense of how the things we're talking about can come together to help with API security, and in general, how that enables effective API security. So with that, let's get going. Again, thank you for joining. So we'll start with the old application stack just to set the context. I think everyone here is aware of the changes that have happened in our industry and in software in the last many years. But we started, not even started, but not that long ago, the network, the host, the application, and the client, right? And this was the stack. This is what we dealt with. And CI/CD happened and DevOps happened because the business said we need to push faster, we need to make change faster, but it still needs to be resilient. It still has to work. And so we made that happen, right? Our industry said, we can be creative. We can add layers that help us with this. So we had containers like Docker and whatnot to enable us to be more fluid in how we work and consistent with how we work with the software in different environments. We added Kubernetes to manage the containers and to add, again, resilience and scale. All of this to add resilience and scale. The cloud, right, so that we could have resilience and scale and innovate faster at the application level, at the networking and infrastructure level. The applications themselves have changed. They're no longer just software on the shelf or downloaded. Many of them are now in the cloud or partially in the cloud, talking to on-prem pieces or in-house developed or just completely on-prem. We've added a layer for identity and access management and cloud identity and access management like Okta and Auth0 on Google's ID system. And so too have the clients changed. No longer just computers. Now we have mobile devices. We have services talking to other services almost as much or probably possibly more than people talking to services. We have IoT devices, so we're in the billions, not millions, of communications and different client types coming in. So why do I take a moment here to cover this? Because this is the modern application stack, but this is also the modern attack surface. Right? And all of these layers in some way or another have this in common. They all have APIs available. Now, we're going to focus on kind of the cloud and up layer here in this talk, but there are APIs at almost all these layers, and really even Kubernetes and containers and all of that are absolutely attack surfaces that are attackable through many different ways, their APIs included. So if I look at that stack a different way, what does that really look like as an application? It means when we look at cloud native applications or API driven applications, we start having these microservices. The microservice architectures gives us lots of small pieces of software communicating together, and those pieces of software have their own APIs around them to give access and control. And they may have their own data. They're talking to many clients, and each of those APIs potentially has a very different business logic that's specific for what that service provides. And each of those APIs may potentially be written by a different team or set of people. And those different people may have different ideas about what security needs to happen around those APIs, or they might have the same idea but not have implemented consistently. See, so there's now a lot of variance here as we expand the stack and as we expand the number of services involved and the communications between them. And APIs are the glue between all these pieces. So to put it another way, if we look at this, is this happening everywhere? Or am I just talking about, a few unicorns? I think we all get at this point, and that's why we're all at this conference, that, this was a prediction from a couple of years ago, which is proven to hold true. 90%, IDC said, of new enterprise applications would be API-driven architectures. And we've seen that push just rapidly. And really what's happened here is development teams have adopted APIs faster than our security teams are able to secure them. And that's where the crisis comes from. And there's plenty of evidence in the news over the last several of years. Major companies, some small, but lots of major and internet-born companies that have been victims of API breaches or suffered API abuses, API security problems. Now, I know usually we don't want to put companies on pages that have had security issues. I think this is about learning, not ridiculing. And I say that specifically because if you think about these companies, all these companies are aware of the value of their brand. They're aware of the importance of protecting their company, their customer data. They have big security teams or security teams and some of the best security team minds working for them. They have security budget. They're buying tools and implementing the tools that are supposed to secure their environments. Well, these companies are not messing around. They understand security and they're dealing with it, but yet we're still having these kinds of statistics. 91% of organizations surveyed by Security Magazine had an API security incident in the last year from 2021. 91%. So obviously something's not working here. So let's kind of take a look into what that might be, why that is, and then we'll talk about what we can do about it. So from an API security perspective, there have been a lot of attempts at different tools and taking different methodologies to help us solve the API security problem. And they do help, but they're not sufficient. So for example, if we look at static application security testing and dynamic application security testing, those tools are great, but they're not really focused at the API level. So they're inadequate for catching API logic attacks. And what do I mean by that? If you think about APIs, why are they different? Because APIs, they really are the business logic and they go straight to the data. So they really need to be properly authenticated and authorized and secure. Bug bounty and pen tests, great, need to happen, absolutely, but insufficient by themselves. Why do I say that? Because they're not comprehensive enough and they're not frequent enough. And quite frankly, the more successful they are, the more expensive they are. And so those need to happen, but we need a broader coverage than that. API gateways, those were originally created for API management, not deep security. And they do authentication and authorization, but they lack the context of user behavior and again, the business logic to really understand these more sophisticated API attacks. And then WAFs, which have for a generation of security, whatever you want to call that, have been the way that we protect our web applications. There's standards that say we have to have WAFs, and they do solve the OWASP web top 10. Things like cross-site, they don't even solve those completely, but they do help. Cross-site scripting and injection attacks and whatnot. But they're signature-based. They're not dynamic enough. They won't detect API abuse and misuse because they don't understand APIs and how they work. And they're not looking across state. They're looking at individual situations and attacks. And so, as well as needing to keep up those rules as we rapidly change our software, WAFs are like solving for playing checkers, or API threat actors are playing chess. I mentioned OWASP. So there's, I think a lot of you, most of you are probably familiar with the OWASP top 10. I now call kind of the OWASP web top 10, which is a vulnerable. So OWASP, being the Open Web Application Security Project, have done an incredible service for our industry by raising awareness and creating projects that help with web security. They have a list, the OWASP web top 10 or OWASP top 10. And they, not that long ago, 2019, came out with the OWASP API top 10 vulnerabilities. These are the top 10 vulnerabilities for APIs. And that should tell us something. If this organization that is deeply invested and focused on making sure our web solutions, our applications out there are secure, created a separate list, they are seeing and understanding that there is a difference between between the types of attacks and how we need to protect against them. Now, this list, the API top 10 list, has things on it like the broken object level authorization, BOLA, which is the highest, most popular, most common attack, and many other things like excessive data exposure, mass assignment. But there are overlaps like injection and, with the web top 10. But even then, they're both on those lists because even injection in APIs looks and acts and needs to be solved differently than injection in web applications. So let's take a look a little deeper at an example to understand a little bit more of what I'm talking about. In this scenario, we are talking about a rideshare company, completely made up, and they have the ability for their drivers to refer their friends to also become drivers, big part of the business. And so that has a special API endpoint as this API for signing up drivers. It's called the join referral. Now this API expects a query from someone who's going to join on a referral. It's going to go ahead and start that process, create a user ID in the backend system, and send that user ID, in our case here, 12345, back to the client. The expectation is that the client will pick that ID up, and then it'll make a request for the get consent details and sending that user ID, because what it needs to do is now get whatever information this backend system has created and get that object and show the right information for the consent for the new driver, and then send that information back. That's the plan. And so this API then is going to get to the ID and then send back an object that has the information for this user. In the attack scenario, the bad actor will use that same API endpoint, but with a different ID. So now they're an authenticated user, but they're asking for the ID of 56789. And the system will happily go and send back now the user object, the JSON object for that user with all of their information. So what's happening here? Two vulnerabilities that we often see together: broken object level authorization at number 1 on the OWASP API top 10. No validation that the current user is actually authorized to see the object that they've requested. And that goes hand in hand with excessive data exposure, where our languages actually do this, makes it convenient and efficient for our development teams to create and innovate, and that's intentional. But the byproduct of that is it's become very easy in our languages to do things like send the JSON object of the user along instead of picking out just what needs to be sent. And what that resulted in was the full object with the personal identifiable information being sent to now a rogue client or a bad actor that was not properly taking out the information that was not supposed to be seen and only using the information from that object, which was the expectation. So the attacker was able to steal personally identifiable records. They stole authentication tokens, and because of that had full account takeover. Now that's one scenario, and if you look at that, you might think to yourself, oh, come on, seriously, people don't make those mistakes, right? People do. We are human. And how do these security flaws get introduced, right? This is rarely developers being malicious. But what we see are things like it's an API from a trusted source, right? Google Maps or Amazon, AWS, or so it should be secure, so I can assume that and move on rather than checking. Now, we also see a lot pressure, time pressure, release pressure. I need to modify this API and I need to get it shipped, so we skip steps, maybe like authorization. Similar, I need to quickly make an API without designing it, right? Somebody maybe came in and requested, hey, that data you have is great, internal, but I need access to it. And the reaction is, well, I'm not going to just give you full access to my database, but I'll put an API around it so that you can request the information I'm ready to let you have. Great, that's a good step. But this goes along with thinking it's internal. And therefore, because it's internal, I don't need to do all of the checking necessary for authorization, authentication. I can be a little bit more relaxed, right? So this is kind of harking back to our days around the network where, outside bad, inside good. You're inside and I know you, it's internal, it's okay for me not to be as careful. And this kind of goes around this notion of zero trust at the application level that we need to be adopting, which is, as a best practice, we should always assume that all APIs may eventually be external. Don't trust that someone's going to be internal or be safe. So internal and external APIs, because what happens is a scenario for, here's an example, internal APIs can oftentimes become external unexpectedly down the chain, out of context of the person who created it. For example, if I have a service I've created internally that is being used by a sales team to get information, for example. And this is great, and they're getting the data that they need, but at some point we have a partner program now, and hey, the business comes to me and says, this has been the best data, we need it, and our partners now need access to it. Well, surprise, now I've got an external API. And things like this can happen, and they do happen. So again, making the assumption that internal is safe is not a good one. We also have a challenge sometimes of the API gateway is, assuming that the API gateway is doing all the authentication and authorization, so we don't need to. So we write our API without thinking about it because something else is handling it. That's dangerous. That means we need a better overall plan and agreement with what is going to be doing that, and ideally checking at 2 points, right? And then, oh boy, I will document it later. We hear this a lot. Busy making features or capabilities. This happens not just as developers, it happens in ops and everywhere else as well. But this allows somebody, or creates a situation where somebody might be making changes or using an API with incorrect assumptions about or incorrect information about the document, about the API, like, for example, is it authenticated properly? So these are some examples of where we have problems and challenges that lead to these kinds of vulnerabilities that we're talking about. So let's switch gears a little bit here and talk about how we should think about this, some framework, if you will, that we can think about the pillars, really, about how we think about how we might want to look at this and start dealing with API security more effectively. We believe it's important to start by knowing your exposure. knowing what your security posture is around your APIs. This is just plain logic. You can't protect what you don't know is out there. So you have to have a good understanding of it, not just know that it's there, but understanding what it is and getting more visibility into it and how they connect, knowing your exposure. Once you know that, it's important, of course, to be able to protect the things that we know about from known attacks like the OWASP API top 10 and the OWASP web top 10 and the business logic attacks and the fraud attacks and the perpetration and the unknown attacks as well, because not everything is known until it's known. And we don't want to fall victim to those things, those 0 days, because we're just not able to do anything, to act on abnormal behavior. And gain security insights. And what is this? So understanding more around your entire system and how all the components work together so that we have a better sense of when something happens in one part of the system, when one API is breached, how that affects or impacts the security of everything around it, and what else might have happened, right? What data escaped, what systems or components or services were impacted, and what's the chain of those that make that happen. And then I have last here, and some would argue it should be first. We'll talk about that in a second here, developing secure APIs. Of course, we want to be making sure that the things that we put out in the first place are secure before they get to production and cause problems. So this means testing our APIs early for security, not just functionality. This means being able to find, identify, and fix vulnerabilities as early as possible. Now, I say, why should that maybe be first or last? It doesn't really matter what the order here we talk about it is, but if you think about this, in a situation where we're under attack, we want to contain the situation, kind of triage and contain the situation. Developing secure APIs is something we need to do absolutely, but it's proactive. And so we need to do both of these really simultaneously, but we need to make sure that we can protect ourselves because, I hate to say it, but we're already clearly seeing out there that we're being falling victim to these vulnerabilities. So it's important with all of these to have not just broad data about what's happening on the outside of the application, but deep data about what's happening on the inside of the application. Now, why would I say that? I think I'll explain that best with a kind of an analogy. Who in this picture here on the slide I'm about to show you, do you think is more likely to find the deeper, hidden, complex problems? Our colonial doctor who can kind of take the temperature and look at the patient, maybe hit the knees, feel the forehead, tickle them a little bit. Not a lot at their disposal back in those days. Or our more modern day doctor who has a CAT scan and MRI can literally see inside the system as the components and the pieces are moving and interacting and see the problem and understand the problem, or as often is the case, see the problem coming because they can see signs or indicators of those problems that they've learned about. Right? Well, what does this look like from an application standpoint? So here we have our kind of generic application. And what we're talking about here is understanding deep and broad data from several aspects. One is user activity. What are they doing? What APIs are they calling? What are their identities? Where are they coming from? What are their roles and permissions? API activity itself, is it happening at the edge? What's happening at the edge? What's happening internal? What are those service-to-service calls that are not on the border? What are the sequence of those calls altogether so that we can understand what are the common sequences that lead to attacks or where we have weaknesses in that series of calls? This, of course, can also help with getting more efficient too. But then also very important is the data, right? Now, data is not the only thing we're trying to protect, although it is one of the very important ones. The data flow. Where is the data flowing across the sequence, across your API calls? How is it getting changed? Where is it getting handed internally? And when does it become an external set of data when it gets pushed externally? And is it properly authenticated? Is it properly authenticated and authorized? Is it sensitive? Is it sensitive data, we need to be more careful with. So all of the information around the data, so we can know when it gets exfiltrated, and we can understand how it's moving through our system. And then at the code execution level, the API parameters and how they change, what's being used in those, and the request response information, not just the headers, but the bodies and the payloads, because that's where a lot of very useful information about what's going on is hidden. And then signals like errors and latency, we have those in our product as well. Those are important because those, although those are oftentimes thought of as performance and monitoring and metrics or signals to be watching, those are also important for security, right? Because those can be indicators of something going wrong or being taken advantage of. So when we have all of this data, and we get that on the traceable side by instrumenting, putting our sensors in as many places as we can on the edge. We can also mirror it from cloud networks. We can inject it into the runtime at the application layer. When we get all of that data, all our observability data, security observability data, and we pump that into machine learning AI. And the reason is because this is a huge amount of data, and we're looking for patterns, and we're looking for behavioral patterns. And we use the AI to generate what we call the application context, the full application context. What is the behavior of the API, the code, the users, the data? What is the risk posture of each API and API endpoint? What are the user trust layers? Like, can we trust these users? And those together enable us to do those things we talked about. Know your exposure, protect your APIs, gain security insights, develop secure APIs. So let's take a look at these a little closer on each of these. We'll start with knowing your exposure. So knowing your exposure is really about being able to see all your APIs, your dependencies, how the data flows, the end-to-end endpoint risk scores, where data is, if it's sensitive. And what we'll do is we'll flip over here, and I'm realizing I'm tight on time. We will look at our the Traceable app, and so we do get an overall view, but and a view of all of the endpoints across the entire system, which might take a minute to generate here on my hotel wireless. Actually, let's do this. Knowing all the endpoints is great. Having them in a big list lets you filter, which you can do. But we also have what we call the application flow. I mentioned what calls what earlier. Knowing that, that's really what we call, it's a dependency list if you think about it. Okay, and so we can see from the north, north-south traffic, what's calling what. We can see internally as we move inside the services of the application, what's calling which services, all the way back to the back end. And if we want to get deeper into any of those services, we should be able to. So we can dive here, for example, into the Nginx Trace Shop service, and we'll take a look at the endpoints. This is similar to the all endpoints list, but this is specific for this service. And what we have here is a risk score that we calculate automatically based on many criteria. This is a summary of that. You can get more details and actually, of course, configure what that is for your organization. But it's based on many different parameters of that roll up to the likelihood and the impact of that API endpoint if it gets breached. And so with that information, we have a good view of what APIs should we be looking at first. But we also want to understand our sensitive data. And part of the discovery that happens is we create an open API. We reverse engineer the open API spec from traffic from runtime, and it's exportable, and it is a full open API spec compatible. You can import your specs or your developer specs, compare them, get conformance analysis of where they don't match. We can also look at the sensitive data and find out where in the specification that shows up. From a sensitive data perspective, we can also go the other direction here, which is looking across everything, not just at a single service, and saying, what are all of the sensitive data types that are flowing through my system? For example, I have credit card CVC here. Now, these are categorizations that you can do automatically. You can also customize. And I'm seeing here that I've got several API endpoints that have this, and I can look at it and come back to the same point and see more about that, including all of the parameters, and even find the sensitive data specifically and get more information about that, the insights that we have on that particular parameter. So here I'm seeing, for example, that this email is, we understand the data type, the data set that it belongs to, etc. So this is visibility from the 30,000 foot level all the way down to the bits and bytes that are making up our API endpoints. And this allows me to really understand what we're dealing with, what we have out there, and whether or not it is aligning with what we believe is out there. So let's move on. Oops, that was the demo. The next one, protect your APIs. So when we talk about protecting your APIs, it's from external and internal attacks. We're looking at the importance of protecting from the OWASP Web Top 10 as well as the API Top 10. And of course, those are just the top 10, so all the others as well. Why the web? Some might say, well, you know what, my WAF has got that. And true, absolutely, you do want to make sure that you have these more known situations, these more known vulnerabilities covered. But if you think about this, an attacker is going to use whatever is at their disposal. Sorry. So I do not disturb. Is going to use whatever is at their disposal. So we want to make sure that, and probably very possibly in conjunction. So we want to make sure that we're covering that. We also want to be understanding the activity of traffic, of threat traffic that's happening, which is very valuable if you can do that for more than just an individual attack. So Traceable actually does that by looking at the authenticated users to the application. We call them threat actors. If they're not authenticated, we track them by whatever information we have that we can align to those users, or just type by IP. And what this enables us to do is really reduce the noise of the attacks and really to show you the timeline of the threat actor within the application. How many attacks did they do? How many IP addresses did they come from? How much of a threat are they to the application? I'll show that in just a minute. We also want to make sure that we're able to protect from business logic abuse. That means understanding how the API should be used and flagging or identifying when they're used in a way that is not normal. And stop data exfiltration, find fraudulent activities, and block those as well. So we'll take a quick look at that. So we'll look here at the protection area. And we do have an overall kind of view of the APIs that are under threat. So these are a roll-up of what is being attacked the most, what is blocked the most, this type of information, how much mitigation is done, how many attackers are there. So good overall view. But let's take the role of someone who's responsible for the daily security of their application. They might get an alert, or they may come in the morning and say, okay, let's take a look at what's going on or what went on. If they're not automatically blocking, which can also be done, they may say, okay, I need to come take a look at this list of the events, the identified security events. take a look at the high events. And let's go ahead and look at an authorization bypass, that BOLA. Now, what we're seeing here is that first we have the overall definition description from the system from Traceable as to why it believed that this was a BOLA attack. So some information that was used or requested didn't show up or get queried initially, so we're not sure where that's coming from. It's unusual behavior. But we have access to the requests, headers, and body. In this case, the body's not very full. And the response header and body, and all the attributes around this attack that we're tracking. Up here on the right, what we call the user API flow, this is the API attack path. This is the kill chain, the set of APIs that the user used to get to the point that they actually attacked at. So we'll dig deeper into that in just a minute. But what I'd like to do now is what we would do in the traceable system, because we can, is you'll notice there's a threat actor identified over here. This is an authenticated user, very stealthily named hacker at dark web, and we can look at more about them. So this particular user, now we've stepped away from just a single attack and we're stepping up into a wider view. What has this user done to our application over time? This is their storyline. This is kind of XDR-like. This is the storyline of everything they've done and tried against this application. They really want to get in. Because of all of this behavior and what the system is seeing, Traceable has brought up more and more their karma or anti-karma, their threat index, right? They've done many different attacks that have different levels of identification for threat, labeled here. And the total of that has knocked them up to a critical level. This is, of course, tunable by each organization. 100 points, this is the maximum points. And the other thing I'm seeing as I'm investigating this is they came from 30 plus, or I guess 31 different IP addresses. That's not normal behavior. So the summation of this leads me to think, I think this is a user that I need to contain. I can go down and I can, let's do that again. I did a little fast. I can change them from an active user to a denied user, or I could suspend them for a certain amount of time. I can do other things with them, but let's just go ahead and contain them. If I confirm now, this user for this application will be blocked for everything they try from here on out. Any other users are fine. They haven't been touched. So I can be very surgical in my containment. So this is good. This means that now I've contained the situation and we can move forward. So gain security insights is the next piece of it. What does that mean? Well, we want to store the data, as much data as we can, about all the transactions, because we know about the bad transactions, but oftentimes the things we don't know are bad. What we consider just normal transactions can actually hold hints and clues and information about broader things. We need to be able to analyze all of the API traffic, not just the requests and response headers, but the payloads and bodies, as we'll see. That's where the information that we're looking for that's going to tell us a lot is hidden. Being able, again, to look at the metrics, to call error patterns there are signals that can hint us off to other interesting things going on that needs more investigation, or that may be indicative of other problems. It's also a data point, a signal that an AI can take and look and see, every time this goes up and that goes down, we see this attack happening, right? So the AI will learn from that. Again, the more data we feed the AI, the smarter it becomes at being able to recognize the problems. And all of this for us is in a data lake that is explorable, and that's what enables root cause analysis and fraud detection and threat hunting. So let's actually go take a look at that. So here we are, again, hacker at dark web. We have contained them. Let's go look again at that authorization bypass. Now, there's this area I promised you would dig in a little bit deeper, so we're going to do that. This was the kill chain. This was the attack point. I can go and dig into the traces, the data, every single call that was made, and get data even deeper into each of those about what was done. So I have all of the context here about that particular attack, but this was one attack. And oftentimes what happens is the attacks come multiple per session, per user session. So I can go here and I can view the entire session. This takes us to our Trace Explorer. This is exploring our trace data lake. We call it that because these are from distributed tracing. The notion of a trace is a collection of spans. A span is a communication between two systems. And the set of those together tells us a story about what was done and what happened and why things happened. So here I'm looking at the session of traces, and these are all lots of information. You can see there's a whole bunch of them. It's a data lake. And maybe in this session, I'm wondering now, I saw that they did Ebola attack, but maybe that wasn't successful. They did other attacks. And the big question is, did they get access to personally identifiable information? I can actually type that in as a query, and I can see, yes, they did. In 2 instances, they got some data out. So maybe I want to dig in a little bit more and figure out what did they get out. So we're looking now at the body of the request. Pretty normal to send a user login and password. Looks like we didn't redact it. We could. Yeah, we did redact it. And then let's look at the response that happened. Now here is where I'm seeing information that shouldn't have gotten out, like a phone number. So there's our PII. And so coming from an attack, looking at the broader session, being able to dig into the data lake and start looking around and figuring out the context and finding. So now in this situation, I can more surgically remediate the situation, or at least I know the user or the piece of data that was leaked or that got out, rather than just knowing that something happened, but I don't know what got out. So that's security insights. And the last, but certainly not least, is developing secure APIs. What should we think about that? Well, there's a lot we can do there. For example, we have those risk profiles or those risk scores for each API endpoint. That allows dev to be efficient in prioritizing what needs to be fixed first, what is the most risky, and even getting deeper and seeing the data about why was it considered most risky to help, again, even further focus on what needs to be resolved to make it less risky. We also detect vulnerabilities in the APIs as they're going by and doing their runtime thing. And we identify those and provide remediation suggestions, because developers are typically not security experts, and security experts are typically not development experts. So we need to provide as much data as we can and bring a point where they can come together and make sense for both sides that are working on it, for all sides that are working on securing our APIs and our applications. Being able, now that we're identifying vulnerabilities, we also want to track the life cycle to make sure that they get resolved. Now that can happen in the system, in Traceable, in our case, or, as will often be the case, exported to an external system that's typically used by development. So we're working in their tool, such as Jira. Being able to compare APIs to best practices and company policies is something that we should be able to do to have secure APIs and make our development processes ensure that. And then being able to run these API security tests, taking maybe known bad payloads and doing conformance tests, etc. They should be runnable in the CI/CD pipeline. You can imagine, for example, that I'm making some changes and I introduce a new API, or I'm making a change to an API and I add it, and the system blocks the pipeline because it says, you just added the use of an API that we've seen in production elsewhere is actually very risky, right? So fix it first, or find a different way, as an example. Or this change that you've made to this API doesn't meet our compliance because the policy says that if you are taking customer sensitive information and handing it to an external system, that you should be authenticated and authorized, and you're only authenticated, right? We could stop Ebola, right? Or at least make an impact. So I'm not going to be able to show you that, but I will show you our vulnerabilities. And that actually isn't part of the catalog. As we look at each API endpoint and get a sense for what those API endpoints have in them. And again, we'll wait as we process here. Again, apologies, I'm on hotel Wi-Fi. So this, what I'm showing you now is the general, what vulnerabilities, here we are, do I have per service. We also can come the other direction, which is as you're looking at an API endpoint, to say, here is the list of vulnerabilities that this particular endpoint has. So here, like the Nginx trace shop, for example, we've got 4 vulnerabilities showing up, like lack of encryption. Ooh, we've done that quite a bit. 66 cases in Nginx trace shop where we don't have proper encryption. I'm going to work on this, but I probably want to track each one and figure out where I'm at with each. I could do it here, or I can export it to Jira up here in the top right. So this will help with the process of securing those APIs and making sure our system is more watertight, if you will. So let's go back and kind of wrap this up. Key takeaways. What I'd want to make sure that you come away with is that as we use APIs and we develop all of this great innovation with APIs, we need to remember the security of these APIs. It is a rapidly growing battlefront. As APIs get used more and more, we have to get our security house in order around them. Everyone does, because it's everyone's responsibility. API security is different than the traditional web application security and other securities. This is a new layer, if you will, of that stack with new methods and new controls that are necessary. We believe that effective API security means first and foremost knowing what you have out there and how at risk it is, knowing your exposure. We believe it means also being able to, of course, protect those APIs at an API level as APIs, because APIs behave differently and they attack differently, they leak differently, and they just are different than the general types of things that we've had to protect against in the past. Gaining insights, security insights, the context around those APIs and when they get used and how they get used, and all of the information around the paths to the attacks and everything is important, because that helps us find problems that we don't know about. We have, for example, at a customer where they identified a problem. First, it was about exposure. That's good. That's always the good first step. Knowing your exposure. We identified an attack that happened, and then in digging deeper through the context, we're able to actually identify that was more of a red herring, a misdirect. And actually, it led to gift card fraud that was happening from an internal employee. And it was really having that context, the insight, and being able to follow that chain that led to that discovery and being able to block that problem. And then, of course, again, always last in this list, but certainly not least, is developing secure APIs in the first place. And really, if we think about DevOps and DevSecOps, right? If you think that infinity loop that we always see a picture of, that's a loop because we need the information from operations, from production, from runtime to loop back into the dev process. And that's true as much for security as it is for any other part of this, of the development cycle and the operation cycle. And so part of that is taking what we learn in runtime and making sure that that can be used to affect how and what we do in the development process to continually improve our security of our APIs. And so really what it comes down to is effective API security really requires having a more full application context than our current tools have today. And that's kind of the main point. So with that, I thank you. I think let me drop out of this, and I think there might be some questions. Let me see if there are. There are not. Okay. Thank you very much for your time. I hope you learned something interesting or valuable that will at least send you off looking deeper and thinking about all of this and the need to, as an industry, rise the tide and secure our APIs better than we are today, and how we might go about that. Again, I'm Dan Gordon with Traceable AI. Please check us out further. We do have a free trial and free version where you can actually at least get to the catalog and start seeing what you have out there. Do check that out. And thank you for your time.